Hey there, and welcome to this explainer. Do me a favor and look up at the night sky tonight. You're going to see that big, glowing, craters and all moon up there, right? We all know it, and we absolutely love it. But what if I told you that everything you thought you knew about our lonely little orbit is, well, kind of incomplete? Today, we're going to completely change how you look at the cosmos, because it turns out our planet has been hiding a secret gang of cosmic tag-alongs. Okay, let's dive right into this. Just think about the number 2 for a second. 2. That is exactly the number of months a tiny, secret mini-moon actually orbited Earth in the year 2024. Literally just 2 months. It hung around, made a few laps, and then, like any polite house guest, it packed its bags and left to just resume its trip around the sun. So this incredibly fleeting visit really forces us to ask a pretty massive question. Does Earth have secret moons hiding in plain sight right now? I mean, we always picture our cool, werewolf-triggering moon as this totally solo act. But Earth actually has a whole crew of strange, intrusive space tag-alongs that astronomers are really just now starting to fully understand. Which brings us to Section 1, the Cosmic Balancing Act. Now, to understand how these rocks stay so close to us without, crashing into our atmosphere or just floating away into the dark abyss, we gotta look at the mechanics. Try to think of Earth's gravity as a giant invisible bubble extending about 1,000,000 miles out in literally every direction. Now, inside this 1,000,000-mile radius, Earth's gravitational pull is actually the boss. It's way stronger than the sun's pull. Our real moon is caught safely deep inside this cozy little bubble. But the fake moons, yeah, they usually sit way outside of it. Let's actually compare these two zones. If an object steps inside that Hill sphere, kind of like our 2024 visitor named PT5 did, it gets caught. It essentially becomes a legit satellite, a true mini-moon. But because PT5 was small and moving incredibly fast, it eventually slipped right back out of our bubble. And the second you step outside the Hill sphere, well, the sun totally takes over. And its massive gravity just pulls you back into the wider solar system. So you're probably wondering, if these other rocks are outside our bubble, how in the world are they moons? Well, it's actually this crazy orbital illusion called one-to-one resonance. This basically means these quasi-moons aren't circling Earth at all. From our point of view, it just looks like they're scribbling lazy doodles in space all around us. But in plain English, they are just making a lap around the sun in the exact same amount of time that Earth does. All right, moving on to Section 2, meet the quasi-moons. Now that we know the physics keeping them nearby, let's actually meet the cast of characters tailing our planet. We've got 4 really famous freeloaders here. We already mentioned 2024 PT5, our 2-month mini-moon. Then there's 2025 PN7. This is a rock that's been tagging along for 60 years, and it's only about 62 feet wide. That's roughly the length of a bowling lane. Then we have 2016 HO3, which is often called Earth's constant companion. It's about 300 feet wide and will likely keep pace with us for centuries. And finally, Kamo-Oloa, a totally fascinating rock with a very special secret that we're going to touch on in just a second. The craziest part? They manage to hide among the stars perfectly because they are so tiny, mostly just the size of small buildings. To brilliantly illustrate exactly how they move, imagine a stickman runner sprinting a marathon right next to you. They aren't running around you in circles, right? They're just keeping the exact same pace on the exact same track. And that is precisely how these quasi-moons maintain their delicate, chaotic balance alongside Earth as we all literally race around the sun. But here is where the story gets really wild. Are these fake moons actually missing pieces of our real moon? I know it sounds straight out of a science fiction movie, but the data we're getting back is painting a super mysterious picture of their origins. While some of these are definitely just your run-of-the-mill near-Earth asteroids caught in a perfect loop, others have a way wilder backstory. Tests showed that the surface of our recent visitor, 2024 PT5, looks remarkably like lunar basalt. And Kamo-Oloa, get this, it reflects light in almost the exact same way as the lunar rocks brought back during the Apollo missions. Because of this, researchers strongly suspect that some of these intruders might literally be chunks blown off our very own moon during a massive impact a long time ago. They're basically cosmic shrapnel coming back to visit us. Let's shift gears to Section 3, the co-orbital gang. So quasi-moons are really just the tip of the iceberg here. Space isn't just calm and empty. It's chaotic. You've got the sun, the moon, and other planets constantly tugging at these small rocks, creating some truly bizarre types of orbiters. First up in this gang, we have the horseshoe orbiters. Imagine an undercover cop in a car tailing you in traffic by constantly switching lanes, speeding up and doubling back so you just don't notice the pattern. From Earth's perspective, these space rocks swing ahead of us, slow down, drift behind, and repeat, forming this giant horseshoe shape in space. Next up, we have the Trojans. These are space rocks hiding in what are called Lagrange points. Now, these points are located exactly 60 degrees in front of us and 60 degrees behind us in our orbital path. You can kind of think of them as gravitational sweet spots, cozy hangout regions where the poles from Earth and the Sun balance out perfectly, creating a totally safe harbor for space debris. To really visualize it, imagine riding a bike. You've got one friend biking way ahead of you and another one biking way behind, but all three of you are pedaling at the exact same speed. Trojans can hang out in these perfectly spaced spots for literally millions of years. Jupiter has tons of these freeloaders, but Earth, we only have a few that we found so far. Now, if a rock doesn't want to sit perfectly still in a Lagrange point, it might be a tadpole orbiter. These rocks are a bit like someone who's incredibly dizzy, just wobbling around those sweet spots in a lazy, bean-shaped loop. They're there, but they just can't seem to sit still. And finally, if that isn't confusing enough for you, we have the jumping Trojans. These are the totally indecisive ones. Picture someone really confused just jumping back and forth between two hammocks. These rocks will spend thousands of years hanging out in the front Lagrange point and then slowly drift all the way to the one behind us and eventually drift right back again. It is a wonderfully weird and awesome cosmic dance. Which brings us to section 4, why fake moons matter. So we have all these bizarre space doodles scribbling around our planet. You might be wondering, why do scientists spend so much time looking for tiny, dim rocks that you can barely even see? Well, let's set up a bit of a showdown. We have the massive, dominant, undeniable presence of our real moon, squaring off against the tiny, almost invisible existence of our building-sized fake moons. They seem totally unmatched, right? I mean, our real moon has some serious superpowers. It controls the ocean tides. It literally slows down Earth's rotation. It stabilizes our planet's tilt. And honestly, without it, our days would be shorter and our seasons would be incredibly chaotic. It also acts as a giant shield, taking the hit from space rocks that might otherwise completely smack into Earth. And of course, let's not forget, it's inspired our calendars, countless myths, and millions of melancholy love songs. It is absolutely the heavy lifter of our night sky. But you know what? Our fake moons have their own quiet superpowers. Every new one we find helps scientists actually understand how objects survive the chaotic gravity tug-of-war in our solar system. They sharpen our detection skills and our models. And maybe most importantly, because they share our orbital path, they are physically closer and easier to reach than almost any other asteroids out there. That makes them incredibly valuable as perfect, low-energy stepping stones for future space exploration missions. They're essentially perfectly placed pit stops. But we really can't get too attached. Unlike our real moon that has literally been with us since the beginning, our quasi-moons are totally temporary. Just like a dog smelling bacon and suddenly bolting to the neighbor's yard, these rocks will eventually get pulled away by the gravity of other space objects. They might stay for decades or even centuries, but eventually, they drift away. There's a quote from the source material that beautifully summarizes this. It says, "They play a quiet role in helping us understand our quirky cosmic neighborhood. By studying these fleeting visitors, we aren't just learning about the rocks themselves, we're actually learning about the very environment our own planet travels through every single day." Which leaves us with this final, really thrilling thought. If Earth has this many secret tag-alongs, entire rocks the size of buildings just hiding in plain sight, mimicking our orbit, and maybe even carrying ancient pieces of our own moon, what else is hiding right above our heads? Next time you look up at the night sky, remember, space isn't empty. It's an active, chaotic highway, and we have definitely got plenty of company. Thanks for joining me on this explainer, and keep your eyes on the stars.